Welcome. In this video, I'm going to talk about permutation of n objects taken R at a time. Okay, so permutation is basically the arrangements where the order is taken into account. Okay, so it is basically arrangements with order. Okay, so permutation is an arrangement of n objects in a specific order. The arrangement of n objects in a specific order using R objects at a time is called the permutation of n objects taking R objects at a time. The notation for permutation is NPK, and the formula is, so NPR, let's write on R here. NPR is equals to n factorial over n minus R factorial. You guys know what is the meaning of factorial, okay? So if you want to arrange, suppose there are n objects, but you want to arrange n objects taken R at a time. Okay, so how many different ways you can arrange n objects taken R at a time is given by this formula. All right, so there is a formula in the calculator. There is a key in the calculator you can use to find out the permutation. It is, again, you should go to the math and then probability and then NPR. Okay, and you enter n and then R. So you think that n is always greater or equals to R, meaning that there are n objects in total and then you are taking R at a time. Okay, so for example, I can give you a very simple example that, for example, suppose there are three balls. They are very similar. They're similar, so this is ball number 1, ball number 2, ball number 3. Okay, so if you want to arrange these balls, then what are the ways you can arrange? 1, 2, 3 is one arrangement, and then you can bring the ball 2 at the beginning, and then you can do 1 and then ball 3 at the second and 2 at the third, so 3, 2, that is another arrangement. And then 2, 3, 1, 2, 1, 3, another arrangement, and 4 arrangements, and then 3, 1, 2, 3, 2, 1. These are the different arrangements. Okay, here the order is taken into account. Okay, so 1 first, 2 and third, and 1 first and then second, 3 and then 2, and that way. So these are the different arrangements when you consider the order. But if you do not consider the order, you have just 3 balls whose number 1, 2 and 3, whatever order you have, they are just the 3 balls with number 1, 2 and 3, right? If you don't consider the order, then it considers just one arrangements, just 3 different balls. Okay, number 1, number 2 and number 3, that's all. But if you consider order, there will be 6 different arrangements. But if you do not consider the order, this is just all one, because there are 3 balls, they are all different, number 1, 2 and 3, that's all. Okay, all right, so we will consider permutation that has order and combination that does not care the order. Okay, so let us do some examples. How many numbers less than 1000 and greater than 99 can be formed using 1, 5 and 7 without repeating any digits? So you can do this problem by the counting principle or using the permutation. Okay, if you want to use permutation, so how many possible numbers, how many numbers you can use? There are 3 numbers you can use, and so all the numbers between 99 and 1000 has to be taken 3 digits. Okay, that needs 3 digits, so R is also 3. Okay, so how many ways you can arrange these 3 numbers taken 3 at a time is actually 3p3, right? So it will be 3 factorial over 3 minus 3 factorial. That will be 3 times 2 times 1 divided by 0 factorial. That is basically 6. Okay, it is same as the similar to this arrangement. So what are the numbers you can make between 1000 and 99 using this 1, 5 and 7? So the total available numbers to use is 3. But so how many numbers you should take at a time? When you consider a number between 99 and 1000, you need to consider 3 digits. Okay, so that means you need to use all these 3. That's why R is equals to 3. Let us see example number 9. Suppose a business owner has a choice of 5 locations. That means the total number he can use is 5, in which to establish her business. She decides to rank each location, meaning she wants to rank all those locations. How many different ways she can rank the 5 locations. So she wants to rank all of those. So how do you do that? Is NPR is equals to n factorial over n minus r factorial. That is 5 factorial over 5 minus 5 factorial. That will give you 5 times 4 times 3 times 2 times 1 over 0 factorial. That will be 120. This is one way of doing that. Another way is just use the principle of counting. Okay, there are 5 locations to rank. For the first location, he can rank 1, 2, 3, 4, 5. There are 5 ways he can rank the first location. There are 4 ways he can rank the second location. There are 3 ways, 2 ways, and then 1 way to rank. So the total is 120. This is another way of doing the same problem. Okay. Now, the second one is if she wants to rank only top 3. So there are 5 locations available to rank, and then she wants to rank only the 3. Okay. So R equals to 3. So how many ways you can do that is 5p3, right? So it is 5 factorial over 5 minus 3 factorial. Okay. So what do you get is 5 times 4 times 3 times 2 times 1 over 2 factorial. So 2 factorial and 2 times 1 are the same thing. So 5 times 4 is 20 times 3 is 60. This is one way of doing that. Another way is he wants to rank only 3. There are 5 locations available. He wants to rank only 3. Okay. So in the first rank he can pick any of those 5. In the second rank he can pick any of the 4, right? Because he ranked the first one already. And for the third rank he can pick any of the 3. So if you multiply, you will get 60 different ways. All right. Now example 10, an inspector must select 3 tests to perform in a certain order. So order matters here. Okay. On a manufactured part, he has a choice of 13. How many different ways he can perform 3 different tests? So it is again n equals to 13, r equals to 3. So you need to do NPR equals to, so 13 factorial over 13 minus 3 factorial. So this will give you 13 times 12 times 11 times 10 factorial over 10 factorial. So you cancel that out. Okay, what do you get? 13 times 12 times. That's what you get. Okay, when you multiply. Okay. Now the thing is, this same problem can be done is he wants to select 3 tests, right? So there are 3 positions available. There are 13 total available, but he wants to fill up only 3. So there are 13 times. For the first one, there are 13 choices available. For the second one, 12 choices, and for the third one, 11 choices. If you multiply, you will get 17, 16. This is another way of doing that. Okay. Now, all these problems can be used by 2 different ways, right? The fundamental principle of counting or the permutation rule. But if there are some of the items are repeated, then you have to use this formula, and you cannot use the fundamental principle of counting that easily. Okay. So let's look at the formula number 2. The number of ways that n objects can be arranged when R1 objects are identical, R2 objects are identical, and RP objects are identical, and etc. is, the formula is n factorial over R1 factorial, R2 factorial, and RP factorial. Let us look at this. Okay. So if there are certain objects repeated, for example, let us look at this. A, B, C, and then B, E, E. Okay. Let us look at how many ways can you reorder these objects to make word. This is one. Another one is A, C, B. Right. This is another word. And then B, C, A, B, A, C, and then C, A, B, C, B, A. If the objects are not repeated, then there are how many? 1, 2, 3, 4, 5, 6. Okay. That is, there are 3 objects available, and you are taking 3 at a time. So meaning you are making word with 3 letters using these 3 letters. So that will give you 3 factorial over 3 minus 3 factorial. That will give you 6. Now you can count here 1, 2, 3, 4, 5, 6, right? But if some of the objects are repeated, for example, the second time you do is you change the order of E and E, you will get the same thing, right? So you don't have to. So another one is E, B, E, and another one is this, move this E here, move this E there, so you will get the same thing. And then another one is B, E, E, B. There are just 3 objects, 3 different arrangements available. Okay, so if some of the objects are repeated, then there are less number of objects. What does it say is, so to find out the number of ways you can arrange is basically the total number of objects, 3 factorial over, so how many times one object is repeated? E is repeated 2 times, right? So 2 factorial. So if we simplify this, 3 factorial is 3 times 2 times 1 over 2 times 1. So you cancel 2 times 1 with 2 times 1. So you will get 3 basically. Okay. So if some of the objects are repeated, you will get less number of arrangements. Okay. So how much less is basically, it depends on how many objects are repeated. If one object is repeated 2 times, you need to divide by 2 factorial. Okay, if there are more objects repeated many times, you need to divide by each of those. Let us do this example and then things will be clear. So how many letters are there? 1 2 3 4 in the statistics. Okay, 1 2 3 4 5 6 7 8 9 10. There are 10 letters in the statistics, but some of them are repeated. Okay, so how many permutations of the letters can be formed, can be made from the word statistics? So there are 10 letters, n is equals to 10. So how many way s is repeated? 1 2 3 ways. Okay, s is repeated 3 times. So s is repeated 3 times. And is there anything repeated? T is also repeated. T. So t is repeated also 3 times. Is there anything repeated? I is repeated, right? I is repeated. So I is also repeated. So I is repeated 2 times. These are the only repeated, other are not repeated. So how many ways you can rearrange the word statistics and make different letters, different word? How many ways can you arrange the letter of the word statistics and then make different word? Since they are repeated, it is definitely the less number of word than if they were non-repeated, right? So the formula says that n factorial over r1 factorial, r1 factorial, r2 factorial, r2 factorial, r3 factorial, and so on, right? So n is 10 factorial over s is r1. So r1 is repeated, so s is repeated 3 times, so 3 factorial. T is repeated 3 times, 3 factorial, and then I is repeated 2 times, 2 factorial. You multiply those, or you can use calculator. Okay, so so if you use calculator, 50400. If you use calculator, you will get 50400. Okay. Next, in how many ways can 3 identical red balls and 2 identical blue balls be arranged in a row? So what it says is there are exactly the similar 3 red balls and then 2 blue balls. Okay, so these are 3 red balls and then 2 blue balls. Okay, they are not numbered, but they are identical, so you cannot distinguish if you change the position of the first and second and third. Okay, so this can be done the similar way. The total number of ball is 5, right? And then the red ball, how many red balls are there? 3 identical. And the blue balls, how many are there? They are repeated 2 times, right? So basically the total number of arrangements will be 5 factorial divided by 3 factorial times 2 factorial. If you use calculator, you will get basically 10. Okay, if you use calculator. All right, the next thing I want to do is the combination. For the combination, basically it is the arrangement of objects, but you don't care the order. Whatever order they come, you don't care those. Okay, so for this, the number of combination of r objects selected from n objects is denoted by NCR, and is given by the formula NCR equals to n factorial over n minus r factorial times r factorial. Okay, this is how you do it. So combination are used when the order of arrangement is not important, as in the selecting process. So let us do some examples. How do I use this formula here? Let's do this 8C6. So 8C6. Your calculator has that. Okay, again you have to go to math and probability and then go to NCR. So his formula says this is like n equals to 8, r equals to 6, right? So 8 factorial over 8 minus 6 factorial, right? And then 6 factorial. This is how you do it. So what do you get? 8 times 7 times 6 factorial. I want to stop at 6 factorial because there is 6 factorial in the denominator, and I can cancel that. 2 factorial times 6 factorial, so you cancel that. that will be 8 times 7 divided by 2 times 1, right? That is 56 over 2, that will be 28. That's what you will get. So what will be 3C3? You just use that same formula. You will get 3 factorial over 3 minus 3 factorial over 3 times 3 factorial. That cancel out. This will be 1. 7C0 will be also 1. Okay. 7 factorial over 7 minus 0 factorial times 0 factorial, right? So you get 7 factorial divided by 7 factorial times 1. That is basically 1. Alright. Let us do example number 13. How many a person select 9 DVDs from a display of 11 DVDs? How many are in total? N equals to 11. How many you want to pick? 9. So order does not matter, whatever order. Okay. Because they are not numbered DVDs. You are not arranging, you are just picking 9 out of 11. So how many ways you can do that is 11C9. So how do you do that? Is 11 factorial over 11 minus 9 factorial, right? Times 9 factorial. What do you get? Is 11 times 10 times 9 times, let me do that, times 9 factorial over 2 factorial times 9 factorial. Okay, what do you get is 55. That's what you get. Example number 14. How many ways can an advisor choose 3 students from a class of 15 if they are each given a different task? If they are given a different task, then picking different students will get the combination of different tasks, right? So it is like ordering. Okay, it works like ordering. If they are assigned the same task, whatever 3 students you pick, you will get the 3 tasks, 3 same tasks, right? But whenever they are assigned a different task, then what happens there is if you pick one set of 3 students, then you will get 3 different tasks. And if you pick another set of 3 students, you will get entirely 3 different tasks, right? So they are all different, meaning that in this case you need to use the permutation because it is like considering an order. Okay, so it will be 15P3. Use the formula 15 factorial over 15 minus 3 factorial. But if they are assigned the same task, whatever set of 3 students you pick, you will get the same 3 tasks. Okay, so how many ways can you do that? Is you will get 3 different students whenever you pick 3 different tasks, but the same work though, same task though. But here you will get 3 different students and 3 different tasks because they are assigned different tasks there. Okay, so it will be 15C3. Okay, the formula will be 15 factorial over 15 minus 3 factorial times 3 factorial. Okay, you can use formula or use calculator to do that. So here you will get this is 15 factorial over 12 factorial. So it will be 15 times 14 times 13 times 12 factorial over 12 factorial. So you cancel that. So whatever you get is the final answer. You will get 15 times 14 times 13. 15 times 14 times 13 is given by 2730. 2730. But here you will get 15 times 14 times 13 times 12 factorial over 12 factorial times 3 factorial. Okay, you cancel 12 factorial with 12 factorial. 3 factorial is basically 6, right? Because 3 times 2 times 1. 3 times 5 is 15. 2 times 7. So 7 times 5 times 13. So 7 times 5 times 13 is basically 455. That is what is left. 455. That's what it is left. Okay. Let's do example 15A. A box contains 6 red balls and 5 white balls. 4 balls are selected. So there is a box that is 5 red balls and then 6 red balls and then 5 white balls. Pick 4 at a time. Okay. How many of them will have all red balls? How many of them will have all red balls? So what do you think? So there will be so how many red balls are in total? There are 6 red balls are in total and you are picking 4 at a time. So it will be 6C4. that will be 6 factorial over 6 minus 4 factorial times 4 factorial, right? That will be 6 times 5 times 4 factorial, right? 6 times 5 times 4 factorial over 2 factorial times 4 factorial. So you cancel that. That will give you 6 times 5 is 30 over 2 is 15. There is 15 of those selection will have all red balls, because there are in total there are 11 balls, right? So what you can do on this problem is, how many are you picking? 4 at a time, right? When you pick 4 at a time, how many of the combination will have red balls? Will be like, you need to pick 6 out of 4 out of 6 red balls, right? And then, but you are picking 4 at a time, so you are not picking anything out of the white ball. So you are not picking anything means you are picking 0 out of 5 and then 4 out of 6. That's how you do it. So 5C0 is basically 1, so this will be 15 again. It's the same thing. Now how many of them will have 2 white balls and 2 red balls? How many white balls are in total? 5. So 5C2 times 6C2. These are the for red balls, these are for the white balls. How many of them will have 1 red balls? 1 red balls will be, so you will be picking 1 red and 3 white, because you are picking the total, you are picking 4 at a time, right? So how many ways you can do that? That will be 6C1 times 5C3. You just multiply those, you will get the answer. So 5C2 will be 5 factorial over 5 minus 2 factorial times 2 factorial. Okay, so that will be 10. So it will be 10 times, that will be 15, right? 10 times 15, that will be 150. So 150 of those selection will have 2 white ball and 2 red ball. Here 6C1 will be 6, okay? Because 6 factorial over 6 minus 5 factorial times 5 factorial, that will be 6. 6 times 5C3 will be 5 factorial over 5 minus 3 factorial times 3 factorial will be 10. That will be 60 in total, okay? So you can use the formula, just use the calculator for 5C1, 5C3 like that. So how many of them will have 3 white balls? You are picking 4 at a time. 3 white ball means 3 white and then 1 should be red, right? So how do you do that? It will be 5C3, because there are 5 total white balls and you are picking 3 at a time, and then times 6C1, exactly the same thing, so it will be 60. Okay, so this is how you do. If you are picking more than 1, you need to use the combination, and if you are selecting 2 different categories, okay, you need to multiply those from each of those category. Okay, let us look at 15b. How many ways can a jury of 4 women and 4 men be selected from 12 women and 14 men? So the total are, so there are 12 women and 14 men available to select, but you want to select 4 women and 4 men. How many ways can you do that? Is 12C4 times 14C4. Just use calculator, you will get a number. Whatever number you get is the final answer. I think there is one more example here, but this is exactly the same as number 14, so you can do that yourself. Okay, so the next thing we'll be doing is the probability and the counting rule. So we'll be using the combination to find out the probability. So far we did just the total number of ways, okay, but we will be doing the probability next. All right.